Good morning or afternoon. This is Physics 1. We're in Chapter 4, and we're going to be talking about motion. We're going to look at the idea of motion. We'll define inertia. We'll talk a little bit about mass, friction, and momentum, because all of these things work together to decide whether something is moving or not. A couple reminders. Energy is what is needed to do work, and that's what we're going to be talking about. Kinetic energy is the energy of motion. When something is moving, it has kinetic energy, and it is doing work. Work, the force needed times the distance the object is moved. So if you put a lot of force into something, you can move it further. Okay. Aristotle, we're back to Aristotle again. You know, Aristotle did a lot of thinking and studying in his day. He was really a good scientist. He believed when you threw a ball that the air behind the ball made it move, as if there was some sort of wind blowing it. He thought all objects moved because of this constant force, that there was something pushing the ball or pushing the object to make it move. Aristotle didn't feel the earth moving, so he taught what's called a geocentric cosmos. Geo means the earth, cosmos means the universe, and so Aristotle taught that the earth was the center of the universe and that the sun and everything else moved around it. Well, didn't happen to be the case, but we didn't know this until 1700 years later with Galileo Galilei, who studied astronomy and studied the movement of the planets and the stars and showed that the earth moved around the sun. He was actually not the first person. Copernicus was the first, but he did a lot of studying on it and showed that this was the case. And then we have Isaac Newton. We've talked about Newton before. Newton developed the laws of motion that we've talked about and that influence what we're talking about today. Now, what keeps that ball moving? Why does it move? Galileo said that things keep moving until something stops them. So that kind of tells us something. There's got to be something to change motion. And Galileo and Newton came up with the idea of inertia, the tendency of things to resist a change in motion. If you have a ball sitting on the ground, it's not going to move. It has a certain amount of inertia until you push it. If it's rolling, it's not going to stop until there's something to change it. Something moving will not stop unless something pushes on it. Okay, let's talk about inertia and mass. Everybody, I think, has bowled, either for real or with a Wii or something like that. We have a Wii, and it's kind of fun to bowl with that. Mass is something that every object has. It's kind of mass and weight for our purposes are the same. Something is heavy, it has a lot of mass. Something is light, it has very little mass. The more mass something has, the harder it is to stop when it's moving. So the little marble that we see on the top picture, little marble is not going to be a very good bowling ball because it has little mass and it's easy to stop. It's going to hit a pin and it's just going to bounce back. Now the bowling ball is much heavier. Bowling ball can weigh between 8 and 16 pounds depending on how strong you are and how much you can pick up. So a bowling ball is a lot heavier. A bowling ball will be moving and will hit the pins and will knock the pins down. Okay, friction is a force that slows things down. Now friction you can kind of feel if you're rubbing things together, it'll get warm. And the atoms of the object are rubbing against the atoms of whatever it's in contact with. And it loses energy and slows down. And some of that energy of motion that's lost translates into heat energy. If you rub your hands together you can feel the warmth on your skin from the rubbing, and that's because of friction. If there's no friction, things would never stop. And you kind of feel that way when you're out on the ice. I don't think any of you drive, but I'm sure you've ridden with your parents or others, and they go to stop on an icy road and you slide a little bit. Or you've been out on the ice, ice skating or walking, and things feel slippery. So that's because there's low friction. Now a spaceship has friction in the atmosphere due to the air. A spaceship rubs against the air molecules, and the air molecules would slow it down. So you have to keep pushing. You have to keep the rockets firing. But once you get into outer space, there's no air. There's nothing for the spaceship to rub against. And so once it gets into outer space, you can turn the rockets off, and it will continue to move at the speed that it was, so that you can save a lot of fuel that way. Now, if you want to go faster, certainly you'll light the rocket again. But once you get into outer space, the spaceship will move on its own because there's nothing to slow it down. Some of the space satellites that we have up are still moving in outer space. For example, the Voyager 1 space satellite has been in space for over 30 years so far, and it's still moving out away from Earth because there's nothing to slow it down. There is no air to cause friction. There is nothing for the space satellite to, shall we say, rub up against, and so it keeps moving out. Eventually it may run into something and then it will stop. Momentum is a function of mass and velocity. The more mass, the more momentum you're going to have, so it's harder to stop. The higher the speed, the more momentum, so it's harder to stop. So we go back to our marble and bowling ball. The marble has a low mass, and even if you throw it as fast as a bowling ball, it's going to have a lower momentum. The bowling ball has a large mass, and it will have a pretty high momentum. Okay, we talked about Aristotle, Galileo, and Newton, and their contrasting ideas about motion. Aristotle thought something was pushing anything that moved. Galileo showed that the Earth goes around the sun. Newton studied the laws of motion and came up with the 3 laws that we talked about last time, and how they influence things. Inertia, the tendency of things to resist a change in motion. You show inertia when Mom and Dad says, get up, it's time to get out of bed, and you just lay there. You don't want to move. You're resisting a change in motion. Mass influences inertia. The more mass, the more force it's going to take to change the motion of something. Friction slows down the object because of contact with another surface. So things rubbing against each other, that rubbing takes away energy from the motion and translates it into heat energy and slows down the thing that's moving. And momentum, mass times speed. The more mass you have, the more momentum. The more speed you have, the more momentum. So if you have a freight train traveling at high speed, you have a lot of mass, you have a lot of speed, and you have a tremendous amount of momentum. It is very, very hard to slow that train down. I have read that sometimes once the engineer puts the brakes on a freight train, it takes over a mile to get that train slowed down to the point where it'll stop. So there we are. Physics is fun. Thanks for being a part of the class, and I will see you later.